All right, so we are doing different types of angles, and angles are a figure that are formed by two rays. Now we're going to call those rays sides, and angles can also be formed by intersecting lines. So that would look like, got a line here and a line there. They end up forming an angle here, and actually there's 4 total in this example. So those two rays come together and they have a common endpoint. That common endpoint is called the vertex. So when I need to name the following, we said the sides are the rays. So this ray starting here at the vertex point, starting at B, going in the direction of A with the ray symbol above it. And then our other side is ray BC, again with the symbol above it. Then the vertex point is the point they have in common in the middle. That's this point B. Now when we name an angle, we're actually going to name it using that vertex point. So I would call it angle B. Well, at this point, if I just write the letter B, I'm actually talking about point B. So I need to know a difference between point B and angle B. So we do have to have a symbol in front of it. It looks like a Pac-Man. It is your angle symbol, so angle B. Now there is another way to name an angle, and since we will have several angles in the future where they overlap and they're next to each other, all sorts of different scenarios, we will use 3 letters. So I would call this angle ABC, or I could call it angle CB. But most importantly is that vertex B is in the middle. So if I look over here, I want to know how many angles do you see? So I notice that there's an angle right here, and they want us to name that angle. So I'm going to call it angle QPR. Notice that the vertex point P is in the middle. And then we've got another angle on this side, and that is angle RPS. But I actually have a large angle that makes up both of those, and that is angle QPS. Now earlier we said we could name an angle based on its vertex, like angle P. Well, in this case, because there are 1, 2, 3 different angles at P, I cannot use only the vertex point. Now, in the future, when we have several angles overlapping all over the page, we will also have one additional way, and they may call this angle here with a 1. So I could call that angle 1. And then over here, this would be a different angle. They may have a number 2 on that, so I could call it angle 2. Now, foreshadowing a little bit, remember we have tick marks for our segments. We can have tick marks for our angles. And these are what those tick marks are going to look like. It looks like a little arced symbol. So we had 4 segments, the segment addition postulate. Well, now we have angles, so we have the angle addition postulate. And last time we talked about this, we said the phrase part plus part equals the whole thing. That's what we did for segment addition postulate, and we're going to do the same idea here. So we are given this first part, angle QPR, this angle here. If I add it together with the second part, angle RPS, then they should add together to equal the whole angle QPS. And that makes sense. If I take this smaller part, add it together with that, it should equal the biggest angle. Now, when I'm talking about an angle, this, we just said its name is angle QPS. Angle QPS is referring to that figure. Well, if you look above, we actually have a little m in front of each angle. That little m, so that means the measure. The m is asking for what is the measure of that angle, and the measure is its number value, its numerical value. So I can apply this angle addition postulate to my next problem. And we are really good math students, and we label our pictures always. So I have on here the angle PQS. If I follow PQS, it's actually the big angle here, that is 77. And then it tells us that PQR is 32. And they're asking us, well, find the measure of RQS, this angle over here. And so when I asked y'all in class, you told me, oh, 77 minus 32, that'll get me this part right here, which is absolutely correct. As a reminder, that comes from your angle addition postulate that says part plus part equals the whole thing. And so that's how we set up our equation. And that's why ultimately y'all told me that we say 77 minus 32, and we were able to get that angle measure. So my final answer says, what is the measure of angle RQS? And its measure is 45. Now, just so that you've been exposed to it, when we talk about angle RQS is 45 degrees because we measure angles in degrees. Well, with the little m in front of it, meaning its measure, the number value of RQS is 45. So one of them would have a degree, the other one does not. Now I'm not going to count off if you add the degree symbol or you don't. I just wanted you to see that there is a difference. So far we've talked about how to name the sides and vertex of an angle, how to name an angle. All of that's going to help you with numbers 1 through 3 on your our assignment. And now we're talking about the angle addition postulate. So that is this example 1 and 2. That's going to help you with numbers 12 and 13 on the homework assignment. So just like earlier, we're really good math students and we label our pictures. It tells us that AOC, so following that letters, that's the biggest angle, is 70. And that AOB is x plus 10. And BOC is x. So following the rule from earlier, we said part plus part equals whole. So for geometry, we're no longer given the equation. We have to come up with it ourselves. So I noticed that part of the 70 is x plus 10. And I notice that the other part of it down here has a value of x. And if I add those two together, it should equal the biggest angle, the whole thing, which is 70. So from here, I just do some fancy algebra. Combine like terms, x and x make 2x. We subtract over 10. Divide by 2, and we get 30. So what's the value of x? The value is 30. So remember, if you are still needing some assistance solving for x, you're coming in for tutoring as needed, because my goal is to explain the geometry and then how and the why are we coming up with this equation. You guys know how to solve an equation, so if you need more time than what I take, then take the extra time that you need. So from here, this is where we plug it in. We're going to take our x value, and they want the measure of BOC. Well, BOC is x, so when I plug it in, I end up with 30. And then I also need AOB. AOB has a value of x plus 10. So when I plug it in, I have 30 plus 10. So again, we have 30 plus 10. So that angle is 40. And it should make sense that 30 plus 40 would have a total of 70. So again, those are going to help you with 12 and 13. Now at the bottom, we are classifying angles. So when you classify an angle, this is asking for the vocab. All right? On your quiz next class and your homework and your test, you will be asked to name an angle and to classify. So at the top, we're going to write a reminder because you get to use your notes for help on the quizzes. When you name an angle, this is when you use letters. So like we did up here, we used 3 letters. Is probably the most common that we're going to use in here. When it asks you to classify the angle, it is asking for that vocab word. Okay? So the classifications you should have learned back in junior high, if not some of these in elementary. An acute angle is between 0 and 90. Oh, it's a pretty angle. It's such a cute one. And then we have an obtuse angle that is between 90 and 180. These guys are obtuse. They over-exaggerate all the time. And then we have a right angle. Right angles are exactly 90 degrees. And then we have a straight angle, which is a straight line. A straight line has a measure of 180. So next they want us to name and classify the largest angle in example 2. So example 2 is right here. The largest angle is the whole angle, this one that's 70. So over here I'm going to talk about number 2. That angle has a measure of 70. So if I were to name it, remember we said naming it is the letters. So my letters are angle AOC. I could call it angle COA, but not angle O because there's too many sides to angle O. Now then we also need to classify it. Classification is the vocab word. That classification comes from its numerical value. It is 70 degrees, so it would be classified as acute. Again, these are going to help you on your homework assignment. Naming it is specifically 4 through 6. Classifying it is 7 through 11. So truly 1 through 11 on your homework should be done in, I would say, less than 4 minutes. So 11 problems in 4 minutes. So then that leaves only 5 other problems for homework. So that's great. So practicing one more time over here is what is the name, what's the measurement, and what's the classification. So in class, while y'all were filling this out, I was busy writing names on my angle. So I was being silly because, no, that is not how we name our angles. We actually use our letters. So I asked you guys, what is Bob's actual name? And you told me angle YFI. It could be angle IFY. In this case, it could be angle F. Now, its measurement is 35, and its classification is acute. So Bob, aw, he's a cute dude. Then we've got Sally over here. Her actual name is angle LTC. You could call her angle CTL or angle T. Sally's measurement is 125, so she is classified as obtuse. So Sally must be pretty dramatic. She's always over-exaggerating. She is obtuse. Then we have Ellen over here. Ellen, her name is angle RTS or STR or angle T. Now, y'all told me the measurement was 90, but I asked why, because there's no number there. But y'all are super smart math students, and you remembered that back in junior high you learned that that box means 90 degrees. So, excellent. So, Ellen is always right. She must have a 100 in geometry, always being so right. Then last we have Frank. Frank, his name is angle NXS or angle SXN. In this case, I probably wouldn't call it angle X. I mean, I guess you could, but since it's a straight angle, it's a straight line, I can see how that would probably make our brain hurt a little bit. So a straight line, a straight angle has a measure of 180, and I actually already classified it for you as straight. So then we have angle bisector. We talked about segment bisectors Excuse me. So now we're going to talk about angle bisectors. Now, if an angle is made up of rays, then a ray is going to be doing the bisecting. So in this case, I have a ray bisecting that angle. Now that ray is going to divide an angle into two congruent angles. And as a reminder, the symbol for congruent is a squiggle with an equal sign. So this says that ray XZ bisects that big angle WXY. Now, if it is bisecting it, it's cutting it exactly into half into congruent parts. So I need to add our tick marks. So anytime you see the word bisect, you definitely should add your tick marks, because that is telling you that this side is exactly half and half. So our angles are congruent, meaning angle WXZ is congruent to angle YXZ. And if their angles are congruent, then their measures are equal. So that's how we would set up these problems that have a bisector. So that bisected ray right there, that is the shared common side. So down here, we're going to look at our information. It says that ray FG is the bisector, and it's bisecting angle EFH. So we actually were given an extension over here that we really don't even need. So here is our angle, and we always practice good math habits, and we label our pictures. We are told that EFG is 5x minus 10, and that GFH is 3x plus 25. So earlier we said part plus part equals whole. Well, they didn't give me any information for the whole thing. The only thing they told me was that it bisects. And if it bisects, then that means that this is exactly cut in half and half. So our equation would say that 5x minus 10 is the exact same measure as our 3x plus 25. Because they are bisected, they are congruent. So from here, we just do some fancy math. We subtract over 3x, add over 10, divide by 2. Yes, you do end up with a decimal. Remember, when we have these, more than likely it'll be basic decimals, 0.5, 0.25, 0.75, not anything difficult. And we get to have our calculators too. So part 1 is what's the value of x. Part 2 is what is the measure of angle EFH. Well, if I follow EFH in words, is that part half, or whole? Well, that is the biggest angle. That is your whole angle. So typically I would go through and plug in this value, plug that value into something that I'm given. I'm not given the whole thing, so I can only plug it into either this part or that part. Well, I know that this top part is exactly half. So I could plug in my x value to that half. And when I do that, we end up with 77.5. Now, I did say a key word, and that key word is half. Well, if I went through and plugged this in over here, you would actually end up getting 77.5 again. So we could do a shortcut and say, well, don't 2 halves equal a whole? And that is correct. So we could say that our final angle measure for EFH is 2 times, let me write it this way, just so that y'all can see what happened. 2 times the 77.5 for a total of 155. All right, our last question, we're again still dealing with this being our bisector. If it bisects, we add our tick marks. Looking at our given information, we are told that GFH is 3x plus 20, and EFH, EFH is actually the whole thing. So again, in words, this is half, and this is whole. So we cannot set these equal to each other because half does not equal whole, but based on our segment bisectors before, we said 2 halves can equal a whole. And so that's how I'm going to set up my equation. 2 of my half, the 3x plus 20, should be equal to the whole angle, that 4x plus 80. So now we've got parentheses, so we've got to distribute. So distributing here. And some fancy math, we subtract over 4x. We subtract over 40, divide by 2, and we get our x value. But they don't want just that. They want the measure of angle EFH. Well, in this case, they did actually give us EFH. So I can plug it directly into that, which is 4x plus 80. So 4 times 20 is 80. 80 plus 80 is 160. But in class, I asked y'all an additional question. And I said, well, what if they were actually asking for the measure of EFG? Well, EFG, they didn't give us anything to plug that into. But remember that this is half, so I can plug it into what is considered half, and that's our 3x plus 20, and so we have 3 times 20, which is 60, and 60 plus 20 gives us 80. And so earlier, remember, we said the whole thing was 160. If it's half, Well, half of 160 is 80, so that makes sense. Perfect. Y'all have the rest of class to knock out your assignment.